yeah, might have done it a little bit late, but I should have showed the progress of our project first. I make a run would kind of pop this thing up. Where the hell is my window? Okay, it takes some time to render. Yeah, here we are stuck. We can. I kind of learned how to work with shaders a bit, and this is from I'm GUI. I'm GUI. If I'm saying it right. I just wanted to see the number of FPS that are rendering on my screen right now. And yeah, I might be weirdly wrong, completely wrong with this thing, but hopefully we'll get somewhere. We'll get somewhere. Yeah, we are just learning, so there's huge margin for learning, at least. In this chapter, we look into several techniques and tricks to debug your OpenGL program. Debugging in OpenGL is not too difficult to do, but getting a grasp of its technique definitely pays out in long run. Okay. GL get error. The moment you incorrectly use OpenGL, like configuring a buffer without first binding any, it will take notice and generate one or more user error flags behind the scenes. We can query these errors using a function called GL get errors that checks the error flags and sets and returns a value if OpenGL gets misused. Hmm. Okay, the moment GL get error is called, it returns either an error or a no error flag at all. The codes that can be returned are listed below. Code 0, no user error reported. GL invalid enum 1280 set when enumeration parameter is not legal. GL invalid value 1281. Okay, 1281 set when a value parameter is not legal. GL invalid operation, that's when, okay, stack overflow. And 5 is for what? Out of memory. Okay, shouldn't be the case, but hopefully not. Might run into it. Set when reading or writing frame buffer. Okay. Within the OpenGL function documentation, you can always find the error codes a function generates it moment it is incorrectly used. For instances, if you take a look at the documentation of GL bind texture function, you can find all the user's error code it could generate using error section. Okay. Error section. The moment an error flag is set, no other error flags will be reported. Furthermore, the moment GL get error is called, it clears all the error flags, or only one if on distributed systems. See not note below. This means that if you call GL get error once at the end of each frame, it returns an error. You can't conclude this was the only error, and the source of error could have been anywhere in the frame. Okay. Note that when OpenGL runs distributedly, like frequently found on X11 systems, other error code can be still generated as long as they have different error codes. Calling GL error then only resets one of the error code flag instead of all of them. Because of this, it is recommended to call inside a loop. Okay. Hmm. So if I just call it out, I'll. Wow. GL text to image makes all the difference in the world. Yeah. Betrayed. I don't know, man. Like I probably shouldn't pay my bandwidth guy anymore. If I go to my while loop and if I just, if I just before starting something or like before ending, I can just where before drawing I can just say add a out uh GL get error. Okay. If I have any errors, like I should probably get it now, or I should see zeros. Make. Oh, okay. Mm, yeah, I'm seeing more zeros than any other thing, but yeah. Uh, I want to get the comments out, Matt. These are kind of annoying. Like, yeah, I got them from where I. Yeah, I want to add in comments that would make sense for me, but these are nothing but pain in the ass for me right now. You know what I mean? Like, ooh. Okay, where are you, OBS? We are doing good, OBS. We are doing good. Ow, ow. Okay, let's go. Let's go. Let's go. Let's go. Okay. And let's go, Mr. Jamie. You guys want to hear this thing? Here's the thing. I mean, this is copyrighted content, which I'm. Hmm. Okay, how long is this thing? Okay. I mean, it's gonna be a long ride, I know. But people did suggest, like, see, 10 years still the best computer graphic course on YouTube.
Time to get started. Let me give you an idea of where we're headed. A bulk of what we will write and do in this playlist, in fact, everything almost that we'll do in this playlist has to do with openGL. Okay, I would hope it has something to do with openGL because that's the name of the playlist. Most of our openGL will be concerned with
Yeah, I think
writing shader.
open buffer data.
Now that we have our red window, I want to actually put a triangle on it, but before we do that, I'm going to get rid of this clear stuff just because for some reason I like the black window more. Nothing against the color red, but black's just more my style. Let me explain OpenGL's coordinate system to you. I'm going to draw a vertical line here as best as I can get a vertical line and
Mm-hmm.
a horizontal line there. Did you like how I got straight lines there? I cheated. I click, and then I right click while holding my left click, and then I click over here, and that gives me a straight line. Anyway, a little way to cheat. Here is the x-axis, very similar to what you do in your algebra class, and this is the y-axis. This location right here is a positive 1 on the x-axis. This is a negative 1 on the x-axis, and same with the y. Here's negative 1 for y, and positive 1 for y. So as long as I draw points in this location, then I should be fine. OpenGL operates on points, or operates using points. We call them vertices. Sometimes we call it vertex data, that kind of thing.
Oh, just hold on a bit. Oh, come on. This is such a pain in the ass thing to learn, ma. This is so bloody frustrating. Yep, we are back online. Not that frustrating, but it does piss me off time to time. Okay. We should be back online right now. We should be properly back online. Yeah, fuck it. Let's just carry on.
Call it what you wish, as long as we give it points and tell OpenGL to work with those points, then it should be fine. OpenGL is excellent for drawing primitives. Okay, You probably aren't going to draw your house with openGL, but you might draw your house using a zillion triangles. That's definitely a possibility. So openGL is good at drawing points, it's good at drawing lines, it's good at drawing triangles, and so a good hello world demonstration for openGL is to use triangles. Let's see if I can get this to work for me. I want to draw a triangle from the top center to right here. Then we'll go from right there to right about here. And then we'll go from there to right about.
So what would this end up be? It's 1 comma 1 and negative 1 comma negative 1 and negative 1 comma positive 1. Those are the
There,
coordinates.
so we'll get this nice big triangle that will fill up our screen. Let's figure out what coordinates we're looking at here. This looks like it will be, let's use red here. We'll use white actually. This coordinate system here, or this coordinate right here, will be 0 in the x and a 1 in the y.
Okay, wait. 0 in the x and 1 in the y. And this will be.
Okay, this coordinate right here will be negative 1 in the x,
Hmm.
negative 1 in the y.
Yeah, I'm right about this
And
one.
this coordinate right here will be 1 in the x and negative 1 in the y. So we need to give openGL these 3 locations, and if we do that properly, then openGL should render this window.
Yeah. Why don't I just give it a shot? Like, the current coordinates. What is it? It's like, uh, when. And this must be for the color, or I might be wrong. Like, you can just say, 0. What am I drawing here? Like, if I take this 0.5, negative 0.5, negative 0.5, and negative 0.5 will be my this down part. If you see, and there's a positive one. What if I just want to fill the entire thing? Right now, it's like make run. The entirety is filled. I mean, some portion of my graphics window is filled like that. And if I just increase my left point to 1, negative 1f, what will be the problem now? Oh, gotta recompile the entire thing. Sorry. Make clean, make run. The triangle should be wonky right now. A little bit wonky. Yes, it is. Oh, no, no, no. No. You notice, like, I kind of fucked with this point a bit. And I could do the same with this one by saying that, for a 0.5, I just want you to be 0. Okay. And I didn't screw with that. Like, yeah, negative 1 and negative 1.0f, and this will probably screw the entire thing up again. Okay. I just want to explore all the possibilities, cause I don't have any time restrictions as of now. I just want to learn whatever I can. In this case, I can just work with the top points. By top one is like 0 and f, and I can just, instead of 0, I can just do 1 point, and it will be touching the top end of the corner, top end of the window. Make a clean, make a run. Bloody hell, it does look like that. And Yeah, color is moving through a spectrum. I could probably control them from sending values to a GLSL using Unicode. If I'm not wrong, Unicode can get me there. Yeah.
So for us, let me just put that off the screen for now. And initialize GL, that's a good place to tell OpenGL about our points. What we don't need to do every single frame is tell OpenGL, here's some points, here's some points, here's some points. Instead, OpenGL, we want to say, OpenGL, here's some points, keep track of them, and when I tell you to draw them, draw them. Initialize GL only runs once for the duration of the window, whereas paint GL will run every time we draw, which will be often. Okay, lots of things cause a repaint. So in this initialize GL function, I want to tell OpenGL about our locations. Now I could say float. I don't know why I wrote flotation, maybe because I was saying location when I was writing float. I could say float, but OpenGL actually, to be platform independent, defines its own data type. So I'm going to say GL float, like that, and if I put my cursor on this and hit F12 to look at the definition, you'll see a GL float is simply a type def for a float. So writing GL float is the exact same as writing float, at least on my platform. GL float verts array. Okay, again, these are going to be our locations. I believe our first location was 0 on the X and a 1 on the Y. The pluses are not necessary, but I like to add them simply because it keeps my data lined up when I'm doing negative values, which we are. In fact, this very next vertex, if I remember, was -1 in the L addition, and R, our 6 floats. I don't necessarily have to put the trailing comma, but I can. And I forgot my assignment operation here. So these vertices, or these floats, are sitting right now on my stack. I've declared them, or defined them locally inside of my initialize GL function. Having them on the stack doesn't do OpenGL any favors. I actually need to copy them to my graphics card, and I need to do that using OpenGL. In order to copy them down to my graphics card, I need to create a buffer object. OpenGL will manage the buffer object for me. I'll even draw the square to represent my buffer object. And when I say buffer, you're probably thinking, or buffer object, you're probably thinking object-oriented programming, which is very similar to what I'm about to do, except in normal object-oriented programming, we explicitly create the objects and tell the objects what to do. But OpenGL uses a C syntax, a programming language C, simply because OpenGL has been around for a long time. And so when we want to do things with our objects, we actually have to call functions. In OpenGL, they're essentially static functions. Anyway, we'll get to that. This is my buffer object. Buffer object that maintains state and information about my buffer. Let's tell OpenGL to create one of those. GL gen buffers. Okay, it wants to know how many buffers it we want it to create. I just want one buffer for now, and then it takes this output parameter, this GLUint pointer. Basically, what OpenGL will do is store the numbers that represent the buffer. Let me just make one of these. In fact, we're going to need it. We'll probably just need it in this function, so I'll do it locally here, even though generally we wouldn't do this. GLUint my buffer ID. If you read the OpenGL documentation, they call this a name. I don't know why they call it a name, because it's not a string, and when I think name, I think a string of characters. So I'll call it an ID, but if you read OpenGL documentation, they'll say, hey, we're giving you the name of this buffer. Right? I pass the address of my buffer ID, and after I've said GL generate a buffer, OpenGL will store inside this buffer ID the ID that represents this buffer object. You can almost think of it like a pointer. In fact, really the only difference between a C++ pointer and an OpenGL buffer ID is a pointer is it's a number that is an actual address out in your virtual process space, whereas these IDs are kind of logical addresses instead. In fact, let me put a breakpoint here, build this, run this, and use the debugger to show you, oh, what's the build error? Link? Oh, I still have it open here in the background. Run it. Hover over my buffer ID, and you see it's not an ugly pointer address. It's actually just a logical address, or a logical number. Buffer ID says, okay, when you say 1, when you tell me to do something with buffer ID 1, you're talking about this buffer I created for you. Right? We've generated that buffer, and now we need to GL bind buffer to the GL array buffer.
So 1 minute. Okay, weird. the ants on my PC?
Binding point. I need to bind my buffer ID.
Mm-hmm.
Right? Now, it took me forever to understand what in tarnation is going on with this. OpenGL has several binding points. Again, they're logical, they're theoretical, they're just there. Anyway, there's several different values I can pass in here, different binding points. I explain this pretty well in my game engine programming playlist, but I'll explain it again here. There's GL array buffer. I don't even know why I'm drawing a box. It's not really worthy of a box. It's just a binding point. Okay, here I'll draw a point. Here's a point. Alright, we'll do 12-point font here, and I'll say this is GL array buffer binding point. What's another binding point we'll use in the very near future? Another binding point we'll use is GL element array buffer. Okay, so these are two possible binding points I can bind to. When I say GL bind buffer, I'm saying, hey, whenever I'm talking about the GL array buffer, I'm talking about the buffer that's bound to that point. So you see how I kind of bound our one and only buffer object. We'll create more of these later. But for now, one and only buffer object I've bound to this GL array buffer binding.
Look at the thing, man. Like, why can't you guys see? Yep. Okay, and if I do this now, yeah, now it works. Oh fuck, man! Like, you guys didn't see shit for what? Like, too long. My bad.
Point. Okay, and I could create another buffer and break this binding here and say, hey, whenever I'm talking about GL array buffer, I'm talking about this other buffer that's bound to the GL array buffer binding point. And I'm not necessarily limited to GL array buffer. I could bind my buffer to a GL element array buffer binding point. It doesn't really matter. But these are two binding points. It's like another level of abstraction that OpenGL moves us further away from our buffer objects. For now, I got array buffer, and I'm binding our one and only buffer to that array buffer binding point. Why is that important? Well, watch this next function I'm going to call GL buffer data. Okay, using this function, I can send down our data about our vertices here in RAM and GL buffer data. And the first thing it asks is, well, which buffer do you want me to send the data to? Well, I only got one buffer, but it doesn't really matter. I still have to be explicit here. I want you to send the data down to the buffer that is bound to the GL array buffer binding point. Right? Very soon we'll do GL element array buffer binding. But for now, I'm just doing GL array buffer. Well, OpenGL looks at the GL array buffer binding point and says, oh, this object. Okay, you want me to send the data you're about to send me down to this object. Hopefully you're getting the point here. This object maintains state about the buffer. There's various things we can set about the buffer. We'll see that soon enough. But when I say buffer data, that actually creates the buffer, actual array of bytes, if you would, that ideally OpenGL will store on my graphics card, in my graphics card memory. OpenGL is not forced to. It's up to OpenGL what it wants to do with that data, but most likely it's going to send this little bit.
I'm generating a buffer and saying that unsigned int, unsigned int buffer my ID, and I'm not adding something. I'm just pointing my GL generate buffers. Okay, I'm creating one buffer and saying that buffer will be related to associated to this particular ID, and GL bind buffer, and I'm saying GL array buffer. Okay, there's an array buffer available, and I'm just binding my buffer ID, which is already okay.
Of data down to my graphics card. How much data are we sending down to OpenGL? Well, since this is a statically defined array and it's defined on the stack, and the compiler can tell exactly how big this is. It's 6 floats times the size of a float. I can just say size of, with the control U to lowercase that, size of verts. I'm sending you down that many bytes. And then this next argument you can't really see, but it's void star data. All right, well, give me an address to the data. Well, the address is verts. It's this array here. Right, you'll find the data there. And then the last argument here is usage, which is a hint to OpenGL. There's various arguments we can pass here. But basically, we're not going to change the data after sending it down to OpenGL. So I'll say GL static draw.
Okay, am I doing that shit? Okay. Yeah, I'm okay. Where are indexes? Uh, I'm just drawing three, so I don't need indices. I mean, it was supposed to be generate element buffer array. No, it's generate GL buffer. Mm, something like that. Uh-huh. I mean, this will come into play after some point probably. Buffer bind data, buffer GL buffer data, and GL array buffer element array. Of element array can just say GL array buffer, and size will be size of vertices and vertices and static draw. Bind buffers. Sort of VBO. What's my buffer name? The vertex buffer object and event buffer object. Do I really need to fuck with them? I'm not really sure. Like, should I? I mean, I can take them apart, then probably have a great chance, but like this should probably break it. You know? Produce some errors. Produce some errors now. Like you have out to throw few errors, so I probably can see that part. Nope. How are you working then? Something is wrong. Make. Nope. Still weird. Some kind of binding event. Where did I create EBO? Unsigned ins. Oh, they have no reasonable values. Like I just created one of vertex array object and vertex buffer object. Okay, doesn't make sense, but still I could use. But if I do indices here, they should probably cross. Okay, wait. They should probably cause an error. Yeah, error is caused, but where the fuck is the error? Okay, error program link error of type program link with uncompiled unspecialized shader error link with. Yeah, that I know. That I know, sir. But what's up with the thing? Like, you know, it should probably have caused an error. If I'm not wrong. Mm, will it be triggered though? Okay, it'll probably look here after I'm done. Where is NDICS? Yeah. This should be a good place to check for errors. Okay. And see make. Oh no no. Make. Yeah. What's up with the error? No error. I mean, I guess those are not the kind of errors which are trying to debug here. Probably a defined file, a header file. Fuck. Where is this function defined, by the way? Nowhere. Okay, wait. GL buffer data target offset void data. Okay. It still makes some sense.
And when OpenGL sees GL static draw, it says, oh, I can probably send this data down deep, dark into some corner of the graphics card that's really optimized, but hard for me to get to and write to. So I'll write it once and leave it there. And the graphics card, however, can read from it quickly. And in theory, that's the idea. It's really up to OpenGL what it wants to do with that. Don't get too hung up on this argument. So there we go. Create a buffer, bind the buffer to the binding point, send this data down to OpenGL. So literally, that OpenGL takes that and copies this data into this array here. And these are just bytes, and copies all those bytes down, hopefully on the... From the last video, we created this buffer. We bound the buffer to the array buffer binding point. Why is that important? Well, because when we say buffer data, we specify the binding point, or the buffer that is bound to that binding point, instead of the actual buffer ID. So here, GL buffer data to the GL array buffer binding point. We're sending down this many bytes. Go copy them from this address here, out on the stack for now. Static draw, just optimize if you want to, no big deal. Here's our window. We sent down this triangle that in theory should go from, let's see, our first point was 0, 1, so up here 0, 1, down to here to negative 1, 1, and then from here we're going all the way to the right, which is 1, negative 1, so 1, negative 1, and then OpenGL, when I tell it to draw a triangle, it will connect that and fill in the rest. I actually need to tell OpenGL to draw this, and in order to do that, I need to do some things with vertex attributes. I don't want to get into all the details of vertex attributes right now. We will quickly soon see why they are useful. For now, I just want to explain that vertices have several attributes. You may be thinking, what kind of attributes are you talking about? Well, the number one attribute of a vertice, for me, and most likely forever, is its position. Okay, this vertex is at 0, 1 in the y, and this one is at negative 1, negative 1, and this one's at 1, negative 1. So the position is one attribute of a vertex. A vertex can have other attributes like a color. Okay, we haven't really specified the color of our vertices here. We can specify normals, surface normals, yada yada yada. Stuff we'll get into later. For now, just know there's more than one attribute. In order to get OpenGL to send the data from the RAM in the graphics card, to actually send it through the processing pipeline, I have to tell OpenGL to enable that attribute. And the only attribute we have right now is position. GL enable vertex attribute array. That's quite the mouthful, but essentially attribute 0, and position doesn't necessarily have to be attribute 0, but since we only have one attribute here, and it is position, it is the first attribute.
Oh, this point. So if I close this thing out, will it still do? Nope. Yep. Somehow I feel that I'm rendering more points here. Three should probably do. I mean, too bad, ain't it? Mm-hmm. GL vertex attribute pointers. GL vertex attribute pointers. GL enable vertex attribute array. Did. Oy, 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 oy. Probably, yeah.
Attributes of the vertex, or the zeroth base, the zeroth, attribute of the vertex. So now I'm saying, hey, enable the attribute array, or enable this data that you copied down to this buffer to go through the graphics processing pipeline. We'll talk about the pipeline soon enough. For now, just trust me. Now that we've enabled that, I now have to describe my data to openGL. When we send our data down to openGL, openGL just says, oh, I'm going to copy this many bytes from this memory location. Nowhere in this function does it say anything about what that data means. You and I can look at it and say, well, it looks like there's 2 floats per vertex, but OpenGL doesn't see that. It just, when we pass that in, OpenGL takes a void star and says, all right, I'll just take this data and copy it down. So now we need to describe our data to OpenGL. So GL
Hey, sup, Rob? Nice to see you. Feels good to see you again, right? Yeah, like, yeah, I've been reading few articles on OpenGL, like, this one which we were following along, like, from past couple of streams. But yeah, like, I got this suggestion that, like, watching these videos kind of help. And yeah, quite frankly, they are making more sense to me right now, like, cause, uh, I don't know, man. Like I'm more of a video learner than a article guy, but like I gave a shot to article, and they're fun too. But right now, whenever I hear someone speaking about something interesting, then I can put my attention towards it rather than reading the entire article myself. You know what I mean? Like, yeah, I'm trying to get my head wrapped around all the small parts right now, so that I can be pretty efficient after some time. And looks like I have a long way to go. Mm-hmm. Yeah,
vertex,
I'll carry on. Like, let me know if you have any questions or like anything you want to talk about.
attrib, pointer. For attribute 0, the only attribute we have, the positional attribute, the size is the number of elements, or floats in this case. So there are 2, and they are floats. So GL, they're floats. I have to tell OpenGL, yes, they are floats. They're GL floats. GL floats. There's 2 floats per vertex. Normalized means, let's normalize these things as vectors. Don't worry about it for now. For now, just say, hey, OpenGL, please.
Since I am passing in 1, 2, and 4 of these colors, like I have to specify. Passing in an extra attribute here, like 3, the third one for the color, if I'm not wrong. Okay.
Faults, don't touch my data. And the stride and the pointer has to deal with how compact this data is. We'll talk about that soon enough. For now, I'm just going to put 0 on both of those. Don't worry, we'll come back to that. So now that we have our data down OpenGL, we've described our data to OpenGL. When OpenGL paints, it's real simple. I want OpenGL to go get that data out of its RAM and render it, draw it. So GL, draw arrays. Okay, mode. The mode is, hey, what kind of data did you send me? Are these lines? Are they points? I'm going to say GL triangles. All right, and by saying GL triangles, I'm saying this, and this are all, consume these 3 vertices as positions of a triangle. So that's what GL triangles means there. The first, well, I want to start out at the first triangle. There's only one triangle, so 0. How many floats are we rendering? It looks like how many triangles are we rendering? It's actually how many floats are we rendering? Or not floats, how many vertices are we rendering? Oh, scratch that. How many vertices, not floats? Well, there are 1, 2, 3 vertices. So 3 vertices, close parenthesis, Control F5, build this, run this. Hopefully, oh, it doesn't link because I still have it running in the background. Close that, run it, and I hope we see a triangle. Look at that. Not too hard to get a triangle on the screen. All right, now you'll see that the triangle is not resizing with the window. Let me show you how to, well, should I do it? Yeah, I'll cheat. I'll probably explain this more later, but for now, the viewport is our view into our scene. Just go by faith for now. GL viewport. Notice the OpenGL functions all start with GL. It's kind of OpenGL's way of doing a namespace. They just said, hey, every OpenGL function is going to start with GL. Okay, the viewport says, hey, what portion of the window do you want to render to? Well, I want to start at 0, 0 in the upper left-hand corner of the window, and I want to render the entire width and the entire height of the window. All right, Control F5, build this, run this, and you'll see the triangle reshapes to whatever the width and height of our window is. And that's every draw. You can see this paintGL is being called essentially every time I resize this, it has to repaint. You can see some flashing there. Now, if I drag this over here, it's repainting portions of the screen. Here's our code from the previous video. I'll execute it, and you can see we have our triangle on the screen. And this
Yeah, we've been through most of the stuff this guy is explaining right now, but uh, somewhere around here, by vertex color or compiling GLSL shader would make more sense for us. Okay. Yeah. I mean, let's
video, I
just
want
go
to
through the entire series. If we are going to do this, let's just do it right.
show you how to draw multiple triangles and how we can optimize that. So I'm actually going to go down here to draw arrays, build, compile.
And just an FYI, like this is the second time I'm trying to get this stream on, and I seem to have a really bad connection in my place right now. So if the stream gets jittery a bit and laggy, we'll try to end the stream a bit early, and I'll get this work done on my personal time in background instead of actually streaming the entire thing. Because like all I'm doing for this particular week is to follow through these tutorials and make some sense out of graphics for myself at least. And yeah, probably after a certain amount of seasoning on this thing, seasoning, thank you, certain amount of seasoning on this thing, when I get used to it, used to OpenGL a bit, like let's try to write something. I mean, an application or a game of some kind. I'm not that efficient yet, but I'll give it a go. Hmm? Yeah, let's just watch this thing together then. I mean, I love the guy who is explaining, by the way.
And run our program again. You can see
Really
I
nice.
now have a black console window, or not? It looks like a console window, doesn't it? It's an OpenGL window, okay? And this time I think the triangles I'd like to draw will go from the upper left corner to the upper right corner into the center. I'll just draw this instead of using my tricks. But I want to do two triangles, essentially one sitting on top of the other. Let me see if I can fill this in a little bit. So here's the top triangle, don't blink. There you go, I can color real fast. I want to do two triangles just like so. And hopefully you remember from the previous videos that OpenGL's coordinate system has an x and a y here. 2 dimensions, positive 1 in the x, positive 1 in the y. That's a 1 right there. Here's a negative 1 in the y, and a negative 1 in the x. So in order to do these two triangles, my coordinates have to be, let's do a bright green. This is obviously 0, 0. This is 1, 1. This is negative 1, 1. So there is our first triangle. And then right here, this triangle, again, is 0, 0. And we can go either way. I can go to this corner first, then this one, or I could come to this one first, and this corner. Later, we'll have to see that we're consistent with our winding order, is what we call that. And winding order is important when it comes to culling, which is something I haven't talked about. So let's ignore that for now. I think let's wind the same direction in both of these triangles. So 0, 0, 1, 1, negative 1, and then again 0, 0, negative 1, negative 1, and then this is 1, negative 1. So you can see that with this top triangle I'm winding counterclockwise, and in this bottom triangle I'm winding counterclockwise as well. That'll become more important later. Let's put these coordinates into our game here, not our game, our OpenGL program. Let's just get rid of these. Ooh, nice, they're still on the screen. So let me do plus 0.0 float, plus 0.0 float, and I'll put a space right here, Control L, Control V, 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 V. So now I have three triangles there, 0, 0, 0, and then we want to go to 1, 1, that's this vertex right here, and then we want to go negative 1. Oh, I forgot my plus signs here. Hold down my Alt key, drag the mouse down, put the plus signs in there, and then, oops, Control L, Control Enter, and that should be good for the first triangle. Wait, negative 1, 1, right?
Okay, where are we going? Like negative 1 and 1, negative 1 and positive 1, positive 1 and positive 1, yes, and 0 and 0 for one, and second one is like 0 and 0, and like negative and negative. Okay, let me try doing something similar there, but I might have to change my. I mean, yeah, okay. Hmm. I mean, this is supposed to be what? Negative one and one, like should be negative zero. Let me fix this up first. Um, 0.5. Okay, that was supposed to be the case here, and if I fuck with it a bit, let me see what will that cost. Nothing. Okay, and cool. What was the coordinates again? I should go from negative 0.5, positive 0.5. Okay, 0.5, 0.5. 0 and 0. This should be a point of contact, right? If I keep one of my points as 0.5 and 0. Can I just say uh 0.5, 0.5? Why do I have negative here? I mean, okay, not this one. I can just do make. Okay, now that's decent. 0 and 0, and 0 and 0 is done. I should get negative 0.5 and 0.5, negative 0.5 and 0.5, and 0.5 and 0.5. These both should be positive. What will positive make? Should be inverted though. Uh, when and this I can say should be 0 and 0 here, and 0 and 0, negative 0.5 and negative 0. Negative negative 0.5 and uh, positive 0.5. Yeah, I got that thing up. Why did you find it troublesome to do it? No, it was quite easy to get that thing down, but yeah, it was pain in the neck for a brief period, like to get this package done and all its dependencies end up in the wrong right place. It was pain in the butt for a long time. But like last stream, I guess you did not join, but like we kind of made it work. My eyes made like I should. I don't know. I always do try to stream for a longer time, but I don't know. Some other way I screw it up badly. Uh, negative 0.5 and negative 0.5 and positive 0.5 and negative 0.5. Positive 0, negative 0.5 and negative 0.5. Positive 0.5 and negative 0.5. If I can, if I may, and I have to just specify uh, the size of the vertices and vertices. And number of draw points should be different.
Here. Then the bottom triangle is again 0, 0, -1, -1, and -1 again. That's this bottom left side of the window vertice, and then we need to get 1, -1. So 1, -1. Now the only thing I need to change in our entire program, we're still creating the buffer, binding the buffer, sending the data down to the buffer. GL draw arrays. Remember right here, this last argument, if I hit Control Shift space, it says, hey, how many vertices do you want me to draw? Well, we were drawing 3 this time. Let's draw.
Yep. Come on, man. I don't know. I kind of think I broke my keyboard. Okay, that's a oddly weird shape to fit it in. Okay, that's weird. That's a weird ass shape. Like I clearly see two triangles, but I don't know how they are aligned in that way. And one is pretty much having glue. I guess that's because I kind of passed in. Oh man. I pretty much passed in the same color for it. I mean, why not? Okay, my triangle kind of ended up like this. Okay. Not in that way. Where are you? Okay, wait. Okay, I have one of my triangles like this, properly aligned, and my other triangle kind of diverged from here and like this. I mean, more of a straighter angle here. If that makes any sense. I can. Come on. Fucking Inkapu website. So this is how they are aligned right now. So let's just calculate the vertex a bit, and then we can be sure. Like the first is 0, 0 points align well. I want this thing to be. Does the order of input matter? I mean, the first one is pretty dang well rendered. Negative. Let me pull this thing out here and let's just compare the vertex, and it's like, the first one is like, okay, come on, don't confuse me that much. First triangle, 0, 0, yeah, aligns, plus 0.5, okay, both plus, and next one is supposed to be uh, plus 0.5 and negative. Okay, it was supposed to be something like this, right? Negative 0.5 and positive. I mean, I don't know if this would make any sense, but probably should get me in good place. Yes, I am in good place. The order of execution matters in this case. Hmm, kind of weird. Um, yeah, I'll take a break for 10 minutes. 10 minutes, like 10, 5 minutes if I'm not wrong. I'll be back in a bit. Yeah, I'll turn my camera off just to be sure that I'm not. I mean, how do I turn this thing off? By the way, Not really sure. Do I just pull the plug? I don't know. If I go video, yeah. Will it be not visible? I mean, I'll be back in a minute, but like I just need to refill my water bottle and use the washroom for a bit. And when I come back, we'll carry on. Yeah, and yeah, no pressure today, Rob. Like, if you want to stick around, you can stick around, but I don't want to tire the fuck out of you just because you're my only go-to resource for every stream. So yeah, you can take rest if you want, but I'll be back in another 5 minutes. Okay. Yeah, we'll be back in a minute. We're back on. Uh, beep 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 beep. Oh fuck, man! I'm gonna turn this thing on. I look like a. It's kind of weird, but yeah, I got myself few snacks, and let's get started on the videos, boys. I'm watching too many videos nowadays. Fucking trying to render triangles here, like, you know what I mean? Trying to bloody render a triangle, and two of them right now, but like, uh, probably I'm quite successful. You know what I mean? And yeah, I got myself few snacks, so I'll not be frustrated. And yeah, just trying to get through.
6, Control F5, build and run. Of course, we get build errors. Why do we get build errors? Linker, do I still have it open? I still have it open. I'm pretty good at doing that, leaving it open in the background. Let's try that again, and drum roll, please. Voila! There we go. There
GG.
are our two triangles, one on top. So now that we have two triangles, I think it's a good time to point out how openGL knows to render triangles here. I just kind of threw this GL triangles down here, which is a preprocessor defined enum. If you Google GL draw arrays, you'll see there's several different values we can pass in here, and they each mean different things. I highly encourage you to do that. But the triangles, when we say triangles, it means every 3 verts makes a triangle. So here is a triangle. Here are 3 verts that makes one triangle. And oh, okay, here's another 3 verts that make a triangle. So the order of these verts matter. If I mix and match these elements up,
Actually did no. Like we just phased it, right? We got order fucked.
I could possibly not get a triangle. I'd connect the dots differently. So when we tell OpenGL to draw something, we're essentially telling OpenGL, hey, here are the verts, and this is the order. Now, this works great and dandy, but there's a problem with it I pointed out in the last video. We have this 0, 0 vert, which happens to be right here, and then, oh, look, it's duplicated right here. Duplicate data, generally not a good idea, especially when we do 3D models with vertices that are shared amongst several triangles and that sort of thing. We'll get a lot of redundant data. So the typical way to solve that is with indices or index buffers or element arrays. Those are all different names for the exact same concept. Let me see if I can drive that home. I'm going to come in here and I'm going to delete one of these redundant vertices. It doesn't matter which one. I can delete anyone. I'll Control L on that line and delete that one. And then now let's bring our window back up and let's label what vertices we have here. So first of all, I'm going to draw the vertices. Here's a vertice. Okay, that's vertice 0 is that 0, 0, and then vertice 1, okay, is that 1, 1, we put that there, and then if I remember right, negative 1, 1, that's up here, so I'll actually label these. This is vertice 0, vertice 1, vertice 2, this is 2, and then negative 1, 1 is down here, so this is vertice 3, and then our last one is right here. This is vertice 4. Well, now we don't have 6 vertices as we did prior, but if I reran this, OpenGL would get confused. It's like, okay, well, you didn't give me that much data, so maybe it rendered one triangle, maybe it just error out. I don't really know. So when you describe your data to OpenGL and or DirectX, doesn't really matter, to the graphics card in general, we're basically saying here are all of the dots, the positions in space, and then we also need to describe how they are connected. When we did GL draw arrays with
Did I get network fucked again? Network fucked, network fucked, network fucked. Network fucked, network fucked, network fucked, network fucked, network fucked. Come on. Throw some balls on you. That's a weird bug. Okay, I've been down for a minute, like, fuck. Yo, I need to have a word with my network operator. The guy's an asshole. What the fuck is wrong with that guy, huh? All I want is some uninterrupted network and basically can't do that. Yeah, like, how long have I been down? Here away? Like, it's the second time I'm trying to stream right now and it's fucking inconsistent. I fucking hate that guy. Motherfucker, like. But still, I mean, even for a 4 or 5 minutes of a downtime, it's still a pain. It's still a pain for me to, whether to carry that stream forward or like just to shut it down and move to bed. I can't decide because the network is too laggy and I have the router right next to me and I don't know, man. Like, to run a proper stream, it shouldn't cost that big of an amount, at least for me. And the guy said the service would be uninterrupted. I'm fucking interrupted right now. Asshole. He's an asshole for a reason. People hate that network and I'm a fucking idiot to opt for them.
GL triangles is the argument here. That means, hey, every 3 verts makes a triangle. That's how they're connected. But now that I've removed
Elementary buffer, let's go. redundant
vert. Instead, what we need to do is use an index array or an element array. It's two terms for the same thing. So how are we going to connect these? Well, it's going to be vert 0, 1, and 2. So vert 0, 1, and 2. That makes a triangle. And then vertice 0, 3, and 4. 0, 3, and 4. That makes another triangle. Now I could have said 4, 0, 3, or I could have said 3, 4, 0. It doesn't really matter as long as the winding order is the same. And even what we're doing right now, we don't need to worry about winding order, but we will when we do culling. Okay, so two main things to be concerned with. One, where are the positions? Two, how are they connected? Well, this is how they're connected, and we need to tell OpenGL to use these indices as our connection points. Okay, so yes, this is a float array, but really you can see how I've grouped two floats into one vertex. Now all of a sudden I can kind of look at this as a vertex array, and I told OpenGL that every two floats makes one vert, so that's why I can get away with that. We need to describe these vert positions to OpenGL, and the way we do that is the exact same way we did it with the vertex information. We do it with buffer objects. So let's go down here, and I'm going to say GL use short, and in the next video I'll tell you why I'm using a short, but for now it's an integral number. It can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's unsigned. We'll say indices. Array gets, I just have to type these out again, 0, 1, I'll move the mouse out of the way. In fact, I'll actually group them close together without spacing per triangle. So our second triangle is 0, 3, and 4, like so. So there are our indices. We need to send them down to OpenGL exact same way we did with the vertex information. We need to do it with creating a buffer, bind the buffer, and send the buffer data down. So let's, I don't want to reuse this buffer ID because this is our vertex buffer ID. In fact, I think I'll change it to vertex buffer ID just because we now are going to have more than one buffer, and I want to be explicit about which int represents what. So GL uint index buffer ID. GL, please gen buffers for me. Gen buffer. I need one buffer, and please stick the logical number that you assign to that buffer into index buffer ID, like so. Okay, sometimes this is called the buffer name. I don't know why they call it a name because it's a number. And then now I need to say GL bind buffer, just like we did before with the vertex buffer, GL array buffer, but instead I'm going to say GL element array buffer. All right, let me actually draw this out one more time because I think it's kind of hard to wrap your head around these buffers and binding points and that sort of thing. Let's just step through this one more time. When I say GL gen buffers, that creates a buffer object, much like an object in object-oriented programming that stores all the state information that you need to know for a buffer. Okay, we just generated this buffer, and we have two binding points. All right, one binding point, let me do in blue here, is GL array buffer, and another binding point, I'll just draw right here, but I'll
okay, wait. Generated a buffer, bind the buffer, GL buffer data, should mention the data where it's from, and vertex attribute pointer, just to define which part I'm okay.
Right here is GL element array buffer. Okay, we created this buffer, this vertex, this buffer that's logical number is stored in the vertex buffer ID, and then we turn around and say, hey, bind it to the GL array buffer binding point. So it's bound right there. And then when I turn around and say GL buffer data, I'm saying, hey, send this data down to whatever buffer is bound to the GL array buffer binding point. Well, here's the GL array buffer binding point, and here's the buffer that's bound to it, so we'll send this data down to this buffer. And it's actually, that's when the actual RAM for the actual vertex float information gets created.
So that's pretty efficient. Like I just need to mention what index I want to read, index I want to use to draw. So that would save me some amount of data on my stack, which I'm copying onto my graphics card, graphics memory somewhere in graphics memory. Yeah, that makes sense.
Sent to the graphics card, and then this buffer object keeps track of that RAM. Well, look, we're generating another buffer here. So when we say GL gen buffers and store its name or logical number inside of index buffer ID, here it is. It's created right here, right there on my screen. I'm sure of it. Could be anywhere. It doesn't really matter. Then I say, hey, bind buffer to the GL element array buffer binding point. This point, not this point. This point right here. I want you to bind the buffer that you gave back to me in the index buffer ID, like so. That will connect this buffer to the element array buffer binding point. I'll make that binding point nice and big. And then again, we just turn around and say, okay, GL buffer data, which
I should probably have this. Element array buffer. I can, instead of buffer data, should have vertices here already. You can just say instead of indices, and pass in indices, and instead of this, I can just say, was it what's the order? uh 0 1 2 and 0 3 4. I mean, this is the connecting point 0, and can eliminate this thing completely, and 0 1 1, come on, 1 1. Fucking wrong with my editor, ma. 2 3 3. Come on, 4. Okay, so it should be somewhat like wait, 2 is a reusable part, like I'll just move it to top, and I'll say 0 1 1 2 3 4. Now I should just probably go in this order, like 0 and 1 3 3 3 is what? How do I want to draw these triangles first? Where are we? Where are we? Yeah, one triangle like this, one more like this, kissing each other. 0 comma 0 is my midpoint, and negative 0.5 and positive 0.5, negative 1, positive 1. If I do my coordinate like this, it's like 0 and it's 1 1 comma 1. And just need to get the diagram first. Where need the actual diagram, would make more sense for me, wouldn't it though? I mean, wait, the order here is that 0 0 and plus 0.5 plus 0.5. Yeah, I should move this here. Okay, plus 0.5 plus 0.5, minus 1 plus 1, minus 1 plus 1, yes, and minus 1 minus 1, yes, plus 1 minus 1, plus 1 minus 1, yes. Okay, now I should go with the order of 0 1 2 and 0 3 4. 0 1 2 0 3 4. Okay, should make same. Yep, should make same and should work same, and reusing too. Actually kind of looks quite good. I don't know why the touching point is darkened a bit, but I guess that comes with the color. Yeah, hopefully so.
well, I'll say that 10,000 times. I know that was, hopefully that was review, but these buffer binding points
Ayo, again, sir. The fuck, sir. I'll take this work off, and I just need to say, and people are, I mean, educated or entertained. Either one of the things I'm doing right, or the rest of the things I'm really getting it wrong. I know, but I still don't like people suffering in my bloody stream for no reason. And yeah, just it's just pissing me off right now. Like the downtimes are too sadistic. You know what I mean? Like, I mean, fuck this. If I get on, I'll just quickly let folks know that I screwed up. I mean, the network is screwed up again. I I know, brother. Yeah, I mean, the downtime was too significant to even ignore. Uh, I mean, yeah, uh, yeah. Here's the FYI, Rob. Like, the thing is that I guess my stream would go down for a significant amount of time if I continue streaming, and it would probably piss most of the people off. So, I probably think I'll call it a day for now. Why am I probably thinking? Like, I'm just saying, like, I'll call it a day for now, and I should have a chat with my network operator for a bit. And yeah, that's pretty much it for day, and no decent progress and fucked up internet. And hopefully I get to see you on the next stream. You're not really pissed by my internet connection. Yeah, love you too, mate. Love you too. Love you every single one who joined in. Really appreciate the effort. Thanks. See you, folks.